Hello students, let us continue our discussion with the capacitor, and we have seen in the last class few examples based on the series and parallel combination of capacitors. We will today discuss the energy loss. Energy loss, what is energy loss? If the two capacitors are there, suppose we have to discuss the energy loss. So we want to discuss energy loss. Suppose one capacitor is this is charged with a battery. This capacitor is C1 and another capacitor is C2. This is charged with the battery. So Q1 becomes the charge on this and Q2 becomes the charge on this. When these two charged capacitors are connected, C1 and C2 are connected, as the capacitance is difference, so the capacitor which is at higher potential will lose the charge, and the capacitor which is at lower potential will gain the charge. So there is a sharing of charge that we are going to discuss, and in this process of sharing of charge some energy is lost, basically in the form of heat, light and sound, like a spark sound and etc. So after the discussion of the last discussion, we want to discuss this energy concept and loss in energy. One thing that I would like to give you the reminder that we have discussed the energy stored. We have discussed that energy stored in the capacitor, energy stored in the capacitor is equals to half CV square. This is the energy stored in the capacitor we have already discussed. You should understand this thing, that energy is stored in the combination of capacitor. This thing I will write as the note. Energy stored in combination of capacitors U is equals to U1 plus U2 plus U3 plus so on UN, and this is valid for both parallel and series combination of capacitors. This thing you should understand very carefully. Now when we connect the two tubes in which the level of water is different, then naturally, and we allow the water to flow, then naturally they acquire the same level and till the level becomes equal. In the similar manner, on combining the two capacitors, their potential will be equal. So I would like to explain here the charge distribution. First I would like to explain the charge distribution. So we should understand what is the charge distribution. In charge on combining the two capacitors, if we are taking two spherical conductors
kept on an insulated stand. Dimension need not to be same. Here some charge is there, here some charge is there, that is Q1, and here some charge is there, that is Q2. Here the capacitance is C1 and potential is V1. Here the capacitance is C2 and potential is V2, and they are kept on insulated stand. Insulated stand. They are kept on insulated stand. Now if we connect the, here there is, its capacitance is different, its capacitance is different, so the charge amount is different, and they are kept on an insulated stand. Now if we connect them by wire, suppose this wire is there by which we have connected them, so after connection redistribution of charge takes place. This was, so after connection redistribution of charge takes place, which we are trying to understand. Redistribution of charge takes place. So after redistribution, suppose here is the same two conductors, here the charge becomes Q1 dash, capacitance remains the same C1, potential V, here charge becomes Q2 dash, capacitance remains the same C2 and potential V. They have acquired a common potential. As in the case of water in the tube, they acquire the same level. In the same way, they acquire the common potential. So in this common potential, we want to find the expression for common potential. Before redistribution, total charge on the system of two conductors Q initial is equals to Q1 plus Q2. There is no confusion. So Q1 is equals to C1 V1 plus Q2 is equals to C2 V2. This is Q initial. This is Q initial. This is the charge that we are getting. Take it as equation number A. And after connection, that is redistribution, that is after redistribution, total charge will remain same. Q final is equals to Q1 dash plus Q2 dash. They have acquired a common potential V, so it is your C1 V plus C2 V. What is V? V is your common potential. So this is equals to C1 plus C2 V. V is what? V is, this is basically common potential. This is common potential. By the charge conservation, therefore, by charge conservation, what we can say? We can say Q initial must be equals to Q final. Therefore C1 V1 plus C2 V2 is equals to C1 plus C2 V. V is the common potential. Better we write common. So we are getting C1 C2. So we are getting V common is equals to C1 V1 plus C2 V2 by C1 plus C2. Now what is here to understand that this is your total charge by total capacity, total charge by total capacity. This thing we have understood. In this process of redistribution of charge, some energy is lost in the form of heat, light and sound, as I told you earlier. So now we will try to calculate energy loss. What is the energy loss? If we talk initial energy of the system, energy initial represented by, I am writing EI, then this is your half C1 V1 square plus half C2 V2 square, that is your 1 by 2 C1 V1 square plus C2 V2 square. 1 by 2 I have taken as common. And now the energy final that is after redistribution, I am representing it by EF is equals to 1 by 2 C1 plus C2 into V common square, half CV square. But V common is how much? V common is equals to C1 V1 plus C2 V2 by C1 plus C2. Hence energy loss must be equals to initial minus E final, that is equals to 1 by 2 I have taken common C1 V1 square plus C2 V2 square minus C1 plus C2 C1 V1 plus C2 V2 whole square by C1 plus C2 whole square. This will give you in this way that we are getting 1 by 2, this square will be cancelled by this term. So 1 by 2 C1 V1 square plus C2 V2 square minus C1 V1 plus C2 V2 whole square by C1 plus C2. Now only calculation is there that we will do, and we will be able in getting the expression for the energy loss. So this can give you 1 by 2 C1 V1 square into C1 plus C2 plus C2 V2 square into C1 plus C2 minus C1 V1 plus C2 V2 whole square, and this whole divided by C1 plus C2. This can be written as, we can write 1 by 2 C1 plus C2, I am taking outside, this multiplication will give you C1 square V1 square plus C1 C2 V1 square plus C1 C2 V2 square plus C2 square V2 square. Now we will have to expand A plus B whole square minus C1 square V1 square minus C2 square V2 square minus 2 C1 C2 V1 V2. This is the expression that we are getting. This C1 square V1 square will cancel with this one, and C2 V2 square will cancel with this one. If we take C1 C2 as common, 1 by 2 C1 plus C2 into C1 C2 as common, we will understand inside the bracket V1 square plus V2 square minus 2 V1 V2. So what we are getting? We are getting, therefore, energy loss is equals to C1 C2 by 2 C1 plus C2 into V1 minus V2 whole square. And this is your positive always. What does it mean? Therefore, E initial is greater than E final, and there is always some loss of energy in distribution. So this tells about there is loss of energy in redistribution of charges. And we have got, this is the expression. So this is the expression for your energy loss when two capacitors, charge capacitors of different capacity, are connected. After this, we should see one example based on this concept. We will see one example based on this concept. Let us try to. So the example is that in this way, that a 10 microfarad capacitor is charged to a potential difference of 1000 volt. 10 microfarad capacitor. The terminals of this capacitor are disconnected from the power supply and then connected to the terminals of an uncharged 6 microfarad capacitor. Find the final potential. What is final potential? Common potential, and the energy lost by the sharing of charge between the capacitors. So in this situation, the situation is in this way. Here is the capacitor, and this capacitor is connected with the power supply, and its capacitance is your 10 microfarad. So when it is charged with a 1000 volt battery, then final potential will be 1000 volt across the capacitor. So what is the charge on the capacitor? Q1 is equals to C1V. Q1 is equals to C1V. So how much we can find? We can find that Q1 is equals to C1V. C1 is your 10 into 10 to the power minus 6 into V is your 1000. This much coulomb Q1 we are getting. Now we have to find first V common. V common is equals to question mark. So this capacitor is removed after getting charge, and it is connected with the another capacitor of 6 volt battery. Another capacitor of 6 microfarad. So this is 10 microfarad and this is your 6 microfarad. So what we can do, Q1 dash, from basic principle, I am not using the formula, I am from basic principle, I am, for your better understanding, I am moving from the basic, by the basic principle. So after sharing, Q1 dash will be how much? Q1 dash will be equals to C1, and what is this is V common, and Q2 dash will be C2 into V common. So by charge conservation, before sharing the charge, it should be equal. That means 10 into 10 to the power minus 6 into 1000 is equals to C1 plus C2 into V common. This is the charge conservation, and we can find V common is equals to, this is how much? This will give you 10 to the power minus 4 into minus 2, 1, 3, minus 3. So 10 to the power minus 3, V common is equals to 10 to the power 10 into 10 to the power minus 6 into 100 by C1 plus C2 is how much? C1 10 plus 2 16 into 10 to the power minus 6 volt, and do the calculation, you will get the answer. This much volt will be your answer. This calculation I am leaving on you now, and it is not difficult. It is simply like this one, that it is your 10 to the power 4 by 16, 10 to the power 4 by 16. Now next thing is there, energy loss. So energy loss is how much? Energy loss is E initial minus E final, that is half C1 V1 square minus half C1 plus C2 into V common square, and this will give you half into 10 into 10 to the power minus 6 whole square minus 1 by 2 C1 plus C2 is how much? 10 plus 6 16, 10 plus 6 into 10 to the power minus 6 into V common 10 to the power 4 by 16 whole square. This much you will do the calculation and you will get the answer in joule. So this I am not joules, joule. This I am leaving you as the homework. You can do the calculation, simple calculation is there, only mathematics is there, and you will be getting the answer. Now in the continued discussion, we would move towards the dielectric. In the continued section, we will move towards the dielectric. This dielectric, first I would explain the meaning of dielectric. We know that there are two types of material. One is conductor and one is insulator. Conductor has its own properties and insulator has its own properties. Conductors are those which allow the flow of electricity totally, that is 100% flow of electricity is there. If we keep a conductor in the external electric field, then inside the conductor the electric field is 0. Now we would like to explain that. Suppose there is a conductor. Suppose here is a conductor. This is a conductor, and in this conductor, this is conductor. behavior of conductor we are trying to understand. It is kept in an external electric field, that is E naught. This external electric field is your E naught. Now what will happen inside the electric field? E net is 0. Why it is 0? Because due to induction, positive charge goes in this direction and negative charge comes in this direction, and an electric field is generated, EP, and this is the applied electric field, E naught, in this direction. So E naught becomes equals to EP, and as a result E net inside the conductor is 0. This is the behavior of conductor, that electric field EP that is induced is just equal and opposite to the applied electric field. This is your applied electric field. Applied electric field. This is your applied electric field. If we are taking the insulator, then electric field will pass as it is. For example, if we are taking an insulator, suppose this is an insulator, the electric field will pass as it is. You see, the electric field will pass as it is. So here is also the electric field E naught, here is also the electric field E naught, here is also the electric field E naught, applied electric field. Dielectric is in between the conductor and insulator. Dielectric is in between the conductor and insulator. Dielectric is in between the conductor and insulator. We are not concerned with the chemical properties of dielectric, only we have to understand the mechanism. So dielectrics are material which are partially conducting and partially insulating. So we can write this thing: dielectric are material, dielectrics are materials which are partially conducting and partially insulating. Such materials are dielectric material. Insulating dielectric contains dipole. Insulating dielectric contains dipole. Dipole is what? Dipole, two charges, center is positive charge and surrounding is the negative charge. The center of positive charge, so what I would say, this is the molecule of dipole. Here is the center of positive charge and here is the center of negative charge, and here the external electric field is 0. Before application of external electric field, the center of positive charge and the center of negative charge are at same point, but the application of external electric field, but if we apply the external electric field, there is a shifting in the center of positive charge and negative charge. E naught applied electric field is not 0. So here what we observe, that there is a shifting in this case. It means that the result of this process, putting the dielectric in external field, what we get, that there is always an electric field a small amount of electric field in opposite direction of the applied electric field. This is the applied electric field and this is the electric field due to polarization. This process is called polarization. So electric field due to polarization, that is shifting of the positive and negative charge. Positive charge moves in the direction of electric field and negative charge against it. So inside the dielectric, what is the value of electric field? This is electric field, the applied electric field minus the electric field due to polarization. This is your applied electric field. Applied electric field. And what is this? This is your electric field due to polarization. Now in this situation, you should understand that electric field due to polarization is generated by E naught. This is generated by E naught, that is the applied electric field. So therefore EP is always less than E naught, always. So EP is always not less than E naught. It means that we can understand in this way. It means that here you should understand in this way that E naught by E naught minus EP, what is this? This is E, is always greater than equals to 1 because numerator is greater and denominator is smaller. And this quantity is called K, that is dielectric constant. This quantity is called K, that is dielectric constant. Dielectric constant means what? One example I would like to tell you. That if K is equals to 3, then E is equals to how much? What is E? E is the net electric field inside the dielectric. Net electric field inside dielectric. Net electric field inside dielectric. What does it mean? It means that E naught by E is equals to 3. So E is equals to E naught by 3. This is the net electric field inside the dielectric. And what does it mean? That is 1 by 3 E naught is left and 2 by 3 E naught is lost. यो lost भइसक्यो. So therefore electric field due to polarization is 2 by 3 E naught. 2 by 3 E naught, E naught minus 1 by 3. So this is the thing that you should understand. If K is equals to 10, that means electric field inside. Suppose if K is equals to 10, if K is equals to 10, then electric field inside K is what? Dielectric constant. Electric field inside dielectric is E naught by 10. This is the thing that you should understand. K is equals to 1 for vacuum, and vacuum is treated as perfect insulator. Vacuum is your perfect insulator. So what you should understand? You should understand it in a better way, that K is 1 for vacuum or for the insulator, and K is equals to infinity for conductor. K is equals to infinity for conductor. K for water, K is equals to 80 approximately for water, and K for is nearly 35, K is nearly 35 for paper. So these are the subject data, you should understand it, and it will give you the understanding of the dielectric. So dielectric constant, and dielectric constant represents these factors, and we should understand it in a proper way, that what is the meaning of dielectric, how dielectric behavior is between insulator and conductor, what is dielectric in terms of applied electric field and reduced value of electric field inside the dielectric. Now one more thing you should understand, that is about dielectric breakdown. A dielectric breakdown term is there, dielectric breakdown. This term has to be understood very carefully. It will be very helpful in understanding the behavior of dielectric. Suppose there is a dielectric, and this dielectric is kept in an external field, and that external field is E0, and there is a reduced value of electric field inside the dielectric. If we consider that this distance is your D, then just now we have seen that E0 by E is equals to K, and potential difference between these two ends, potential difference inside the dielectric, delta V is equals to E into D. This is the rest amount which is reduced. If delta V exceeds a limit, the material of the dielectric may get damaged. That is, the chemical property will change and dielectric will not remain the dielectric, and the material dielectric becomes conducting. This event is known as dielectric breakdown, and this value of delta V, potential difference, is the dielectric breakdown potential. Potential is caused by the external field. This delta V is caused by E0, that is the applied field. So dielectric is expressed, so dielectric strength is expressed in terms of E0. Dielectric strength is expressed in terms of applied electric field. Applied electric field E0. So for example, just now in the earlier examples we have discussed that dielectric strength of the air is 3 into 10 to power 6 volt per meter. Dielectric strength is expressed in the form of electric field. If we exceed the value of electric field more than the dielectric strength, breakdown results. For dielectric strength for air, dielectric strength for air is 3 into 10 to the power 6 volt per meter. For vacuum को लागि यो कति हुन्छ? Dielectric strength for vacuum is your infinity. And mica, which is maximum used, mica is a silicon compound which is maximum used, its value is 12 into 10 to the power 6 volt per meter. So this is the dielectric, dielectric strength, breakdown voltage, breakdown potential, and all these things, and all things related with the dielectric. Now I would like to finally discuss a question, an example based on this concept. What is that example? Example is in this way. You are suppose you are given a dielectric. Suppose you are given a parallel plate in this way, and here is the charge plus Q, and here is the charge minus Q. We have inserted a dielectric inside it. This dielectric has the dielectric constant K, and if E is the electric field inside dielectric, E naught is your applied electric field. Now see, E naught will have this direction. E is the reduced value of electric field. This is reduced. Due to this, here will be some charge, that due to polarization some charge will develop, and here will some charge develop. This charge I am saying as QP, and you have to find this value. That means you have to find charge induced on the surface of dielectric. Find charge induced on the surface of dielectric, QP. This is the question. Now how to solve this question? Initially Q charge was there, and QP is the charge developed on this plate due to polarization, and you have to find the value of QP. Now what I would like to tell you, here, net charge on this plate is A, this plate is B. So net charge on plate A is equals to how much? Q minus QP. So electric field due to this will be what? Sigma by epsilon naught. So electric field Q minus QP by A epsilon naught must be equals to E naught applied by reduced value of electric field, and E naught is what? Q by epsilon naught A into K. So epsilon naught A will cancel, and what we are getting? Q minus QP is equals to Q by K. Therefore QP is equals to Q minus Q by K. This is your answer. That is electric field due to, what is this? This is, I have written, actually I have used here the formula E is equals to sigma by epsilon naught, that is Q by A epsilon naught. This formula I have used here. So this is the way we have discussed about the dielectric, and finally I would like to suggest you that practice these things in a very efficient way, repeated way. It will help you in building the concept. Clarity of concept will take place, and the more you will practice, the more you will reach near to the perfectness. In this way we have finished the capacitance. Now in next video I will discuss few selective questions based on this capacitance and dielectric, and then we will start some other section.